This is the second time I've had to record this because the audio was terrible, and if I have to do it again, I'm gonna jump out a window. I love the holidays and especially having decorations around the house, but the worst part is always when they need to be taken down at the end of the season. But what if I had a decoration that could stay up all year round, automatically changing based on the current holiday, season, and even birthdays of my friends and family? Welcome to part 1 of my custom LED grid project, where I'll be laying down the groundwork code that'll allow me to display whatever I want on one of these panels. Hello! My name is Nathan, and this is Guh-Roo's Gadgets. I should preface this first video by saying that I am relatively new to the world of electronics, but I do have a strong background in programming, and I even do it professionally. This means that the first few projects I work on this channel will be more focused on the code involved, rather than the physical components. As I continue to learn and become more capable in working with Arduinos and everything that comes along with them, my hope is that that will be reflected in the complexity of the electronics portion of what I'm able to create. This channel is also meant to be at least 1% educational, so while some things I've already done for part 2 are improvements of the version I'm about to present, I think it's important to show as much of my thought process as I can to better document the project's progress for myself, as well as demonstrate how to make upgrades to code for anyone still learning. That being said, where do we start? No, after that. Before that! The idea for this project came about when I was looking for some digital picture frames on Amazon. They rotate through a set of photos and videos like any screen can, but that's about where the features seemed to end. None of the ones I saw seemed very customizable, and I wanted the ability to not only rotate between pictures of friends and family, but also to automatically display backgrounds based on the time of year. This would include albums for holidays like Halloween, Christmas, and Easter, as well as snowy landscapes in January and forests and beaches in the summer. I actually already do this exact theming for my phone and computer backgrounds. Now you might ask why I'm bothering with this project when I could just buy a few digital picture frames or cheap displays, figure out a way to program them myself, and save the rest of the headache. Well... Wait, crap, why didn't I just do that? Joking aside, there are a few genuine reasons. The biggest one by far is that I've been wanting to get into working with electronics as a hobby for years, and this seemed like a fun first project to do that still has a primary focus on the programming side. Secondly, I have worked on video games in the past, including a custom game engine, so the challenge of getting images to display in LEDs isn't too far away from what I already know how to do. Lastly, these panels can actually be chained together to create a larger display, which means I can easily modify the overall design to either fit into a tight space or cover a wider area. Combine all of this with my fascination with houses that synchronize their holiday lights to music, and you can see how we ended up here. Now to discuss the overarching plan. The rest of this video will be covering how I got a single panel of LEDs to display whatever I want, including images from PNG files. But before that, let's briefly go over where all of this is heading. I should also say that the specific panels I'm using are these ones I found on Amazon from BTF Lighting. They seem to be pretty good quality so far, and no, I'm not being sponsored by them to say that, although if they want to send me some free ones, I won't exactly say no because of how many I've been using. I only mention them by name in case anyone wants to make something similar. Shout out to this Chris Maher video as well, I hope I'm pronouncing that correctly, since I discovered it while researching the panels and it clued me into the wiring for the power. The end goal of this project is to have a grid of 8x4 panels, exact size pending, arranged in a 3D printed frame. I've seen other people online make similar projects with these panels and found this design for one that also diffuses each LED into a square pixel. Part 2 will go into modifying this model to accommodate larger grid setups. Oh, and as a quick side note, a related issue I've run into is that it can be a bit hard to tell what some of the images are supposed to be, and black pixels don't really read that well at all, but this frame will actually fix both of those issues. Now, obviously it won't be able to properly show full images like those digital picture frames due to how many pixels are technically in this grid compared to a digital picture frame. And to get around that issue, I'm simply going to use pixel art. While pixel art does work for general themes and holiday decorations, it does unfortunately mean I won't be displaying any pictures of friends and family on them. However, it will at the very least remind me of any birthdays as they happen. Building off of that last point, I don't want the grid to just be decorative, so it will also display handy information at a glance, such as the time, date, and potentially even the weather if I can get that figured out. If anything, this information will be the default state. There will be decorative borders based on the various themes that will be surrounding the main section, and the colors of the text itself will vary based on the date as well. So for example, the text will be blue and cyan in the winter, red, white, and blue around the 4th of July, red and green for Christmas, and so on and so forth. Along with birthday reminders, there will be other date-related messages such as saying happy whatever holiday, and these will be displayed either above or below the primary section. Depending on the length of the text, they'll either be stationary or moving across the grid like a text roll at the bottom of a news program. Additionally, there will also be the occasional random message and trivia. Speaking of trivia, another core feature the grid will have is hourly scenes. What I mean by this is that at a random point in every hour of the day, so 24 times a day, there will be a transition that clears of the grid and does something more dynamic. As I mentioned, one of these things will be random trivia questions. Other ideas I had for this include Who's That Pokemon, the Idol DVD logo animation with random sprites based on the current theme, and demo modes of older games like Tetris or Snake. On the topic of games, have you heard of a little game called Raid Shadow? But enough about the future, let's get into what's working so far. First of all, I had to get situated with the Arduino environment because I hadn't used it before. The programming language used by Arduino is a variant of C++, which is great because that's the one I'm strongest in. Some time ago, I got a kit to mess around with learning simple electronics concepts, and it included an Arduino Mega board. This board is what I initially used to get the first few things working on the LED panel, but after some research, I decided to swap to an ESP32 board. It's overall faster, has more memory, and I'm planning on utilizing the built-in clock, Bluetooth, and Wi-Fi capabilities for later features. This was a more relatively recent change in this project, which is why some of the clips are still using the Arduino Mega. There were definitely a few headaches with this transition though, the most annoying to debug being that file names on the ESP32 requires a slash in front of the name, while they aren't needed on the Arduino Mega. Moving on to the actual grid, the first thing I needed was a library that allows me to work with chains of LEDs, since that's how these panels are wired. Now I do want to be the one that writes all of my code for my projects so that it feels more personal, but this is one of those instances where it's so low level that it would be a waste of time to do it myself. I'm much more interested in programming the LEDs without needing to worry about anything beyond sending RGB values, and trust me, there is still plenty left to program. That being said, I found that the Fast LED library would suit my needs to do exactly that. It handles the low-level portion of lighting up WS2812 LED strands, which are what's inside of these panels. After some setup, it provides me with a one-dimensional array of 256 RGB struct values, one for each LED in the panel. Setting any of these values and sending the update command will make the corresponding LED light up. My fellow programmers out there might take a look at this grid and think, oh, this is easy enough to create images on, but it's slightly more complicated than generating ASCII art. Thinking of the panel as having XY coordinates, with the top left corner being 0, 0 and the bottom right corner being 15, 15, you might expect it to function like a standard 2D array, where it goes left to right, then after reaching the end of a row, it resets to the left side of the next line. However, looking at this simple program that lights up each LED in the Fast LED array in order, it actually goes down. Okay, no big deal. I can just rotate it 90 degrees and reverse the Y direction so that it goes left to right, and then after each line it goes up, right? Well, after reaching the end of a column, it goes directly to the next LED to the right, and then continues in a snaking pattern across the entire panel. Okay, this does actually make sense when you think about it electronically rather than programmatically, because when laying out the LEDs, it wouldn't make a lot of sense to have a bunch of extra wire to run from the bottom to the top just for the sake of appeasing the programmers. Taking this new challenge into account, my first goal was to be able to light up any LED I wanted, given XY coordinates. This meant making an equation to convert from the coordinates to a position in the array, and this is what I came up with to do that. Breaking this down, the first part is a ternary operation that checks to see which column we're in. Due to the snaking pattern, moving down in the positive Y direction will mean having ascending values in the LED array for every other column, and the rest of the columns then will have descending values as they need to make their way back up. So to reach the proper array value, a Y value of 3 in column 0 requires a movement of 3 spaces from the top, whereas a Y value of 3 in column 1 will require movement of 15 minus 3, so 12, spaces from the bottom. The X coordinate is thankfully much simpler since you just need to move ahead 16 spaces in the array for each increment of X. So an X value of 3 will require a movement of 48 spaces. All that's left is to add these values together, and combining our previous examples, an XY coordinate of 3, 3 will give us an array value of 60. After figuring out the method for lighting up single pixels, I moved on to creating functions for setting a single color for an entire row, an entire column, and the whole panel. The panel was by far the easiest since you just have to set the entire array at once. The columns were also very straightforward since all of the LEDs in the columns are right next to each other. The rows were a bit trickier since there are gaps between all of the pixels that need to be lit up, but I figured out that all I needed to do was have 2 gaps calculated between each of the LEDs. Looking at the top row as an example, the first LED to the second LED has an array gap of 31, versus the second LED to the third LED is right next to each other, so only 1. This pattern holds for the entire row, and as you move down the rows, the first gap shrinks while the second grows. Making these functions might seem a little arbitrary, but they were crucial for the next challenge, which was displaying an image. The image class that I made is pretty straightforward. Its main components are another list of RGB values, exactly like how the panel's values are held, as well as its width and height. The top left corner of the image represents its location, and this logic will hold true for every other object type that I'm going to bring up throughout this project. There were a few iterations of the function to transfer the RGB values from the image to the panel, including an attempt to draw chunks in column by column instead of each pixel manually. While this would have been more efficient, I ultimately didn't go with this approach for a couple of reasons. For one, it would mean needing to reverse the image data for each column due to the snaking pattern I discussed earlier. I also just didn't think it was worth the time since, like I said, I did have a version that works where it sets every pixel individually, and if this method proves to be too slow at handling images for the entire grid, given how many images I know will be implemented at one point, I'll go back and modify it in the future. My goal for now is just to get everything working. However, that's not to say that the current version is completely unoptimized. The best example of this is a form of culling for parts of the image that are off-screen, so to speak. Obviously, an image can be much larger than the 16 by 16 pixels provided by a panel, so before any drawing can take place, the panel's draw image function automatically cuts out only the part of the image that is in frame. That way, when it does draw each pixel, it won't waste any time iterating over pixels it would just skip over anyway. This is the first demo I made, which shows off lighting up rows, columns, the whole panel, individual pixels, and finally a moving image. This last part actually made me aware of an edge case error in my draw image function, where the wrong section of the image would be displayed when it was partially off screen. The next step after this was to create a sprite class, which, for my purposes, is defined as an image that includes coordinates and other features depending on the specific type, such as animations. My first idea for animations was to have the sprite reference multiple image objects, but after giving it more thought, I quickly realized that sprite sheets were the way to go. For anyone that might not know what a sprite sheet is, it's essentially just a giant image that contains all of the animated frames of a sprite in a grid. That way, sprites can simply grab smaller sections to display multiple images while only referencing one. Most video games that utilize 2D animated art use sprite sheets for this exact purpose. My current sprite class has XY coordinates for where it should be placed in the grid, a reference to a single image, a toggle to say if the image is a sprite sheet or not, and a rectangle class which contains the XY coordinates and dimensions of the current image subsection to show. All I needed to do was add a drawSprite function to the LED panel class, which uses the drawImage function that was modified to also take in a rectangle parameter. The method I'm using here to let the sprite know which subimages to use is a little limiting, but it's really all I need at the moment, and is super easy to amend in the future if needed. And spoilers, this is actually the first thing I overhauled for part 2 because I immediately needed a better framework for rendering text. Taking inspiration from everything else I've done thus far, and using this custom sheet I made from this one I found online, the sprites act as a 2D array. To iterate through an animation, 3 values are held, which are the first position of an animation, the second position of an animation, and the current position to actually use. For moving to the next frame in the animation, all I need to do is increment the current position value. To have it loop, I reset it to the start position once it gets beyond the last position. Like I said, there are some obvious limitations to this method, which is why it's already been replaced. Each animation can only use adjacent images, so there's no mixing allowed, which means that repeat frames need to have another copy of the frame as seen in the run animation here. All of the sprites also need to be of uniform size, or else the whole method breaks down if they're not properly aligned. Again, this version was only meant to be a lightweight proof of concept, and it served that purpose well. Given the size of all of the image files that I know will eventually be required, I added an SD card reader to store them. You might have been wondering how I'm actually getting the RGB data from the PNG files, and the answer is that I'm actually converting the images to .txt files before they're even on the Arduino. The format is nothing special, with line 1 containing the image's width, line 2 the height, and line 3 all of the RGB data in hexadecimal format. These .txt files were later swapped for JSON files once the complexity of the required data rose, but that's another topic for part 2. In order to do this file conversion, I actually reused part of an old project I did in grad school where I made a custom game engine. There was a sub-project that converted various file types to something that the engine can read, including GLTF files for 3D models and PNG files for images. It was fairly straightforward to branch off of this code to make it generate the format I needed. Using these converted files is much more efficient than the timely process of trying to parse through a PNG file on the Arduino itself. However, after realizing that any file conversions I needed to do could only happen on my desktop PC in an admittedly clunky method, I decided to quickly write up a new converter in the form of a command line script in Swift using this PNG library. Now I can quickly create the files for my MacBook while traveling. I actually prefer this method because it's more streamlined and all I have to do is open a terminal and any folder that contains PNGs, run the script, and be given a folder with all of the new files. This is an excellent example of why you should never get married to your code or any one specific tool method. The Game Engine project is also where I built the Object Manager library that I'm using to pull the image objects. Since multiple sprites can use the same image, only one is needed at a time. When a new sprite is created, it will check the manager to see if the required image already exists by searching for its file name before making a new one. Each image also has a reference counter, so when the manager is flushed, it won't delete anything that is still in use. The next primary feature to talk about is a way to display text, but that will actually be left for part 2. Thank you so much for watching. If you're still here, you're probably interested in future videos on this channel. I'm currently planning on releasing a new video every 4 weeks on Fridays, but this might vary depending on how much time I'm able to dedicate to these projects, since I do also have a full-time job. It is super awesome to finally be able to share these things that I'm making. Not only the video itself and the electronics and the programming, but even the music. I actually made all of the music you've been listening to throughout this video, either specifically for this channel or from previous projects I've worked on. I'm very excited to create some gadgets, as well as look back and see my progress while it's being documented. Also, part 2 of the Broombot video is coming next. It just needed more time to finish editing because it is quite long. But for now, farewell, thanks for watching, and don't forget to subscribe.